Hello, and welcome to the Tentative Tutor channel. I hope you'll enjoy these 6 unusual puzzles with surprising solutions. Four prisoners were given a chance to be freed by the warden. He told them he has 4 hats, 2 red and 2 blue. If any one of them can guess the color of their hat, they will all be set free. They were lined up as shown, where each prisoner can only see the ones in front of him. They can't take off or see their own hats. They cannot speak to the other prisoners, and each prisoner will only guess if he can arrive at the answer through pure logical reasoning. So they must base their answer only on the color of the hat or hats on the prisoners in front of them. Can the prisoners get freed, and if so, how? We can see that we have exactly 6 possibilities as shown for arranging the hats on the 4 prisoners. Note that prisoner 3 and 4 couldn't possibly make a guess, as they are only facing the wall and cannot see the other prisoners. First, if prisoners 2 and 3 have the same color hat, prisoner 1 will be able to deduce that his hat must be the opposite color, as there are only 2 of the same color. So, for instance, if he sees that 2 and 3 in front of him are both wearing red hats, he'll know that his is blue. So we can eliminate the 2 arrangements in the list above, leaving 4 arrangements of hats to consider, where in each of these cases prisoners 2 and 3 have different colored hats. So if enough time goes by and prisoner 1 cannot guess the color of his hat, prisoner 2 will deduce that he and prisoner 3 must have different color hats, as those are the only options remaining. He then only has to look at 3's hat. If it's blue, he will correctly conclude that his is red, and if it's red, his must be blue. So either prisoner 1 will be able to guess his hat's color, or if not, prisoner 2 can use that information to guess the color of his hat. So in all cases, the prisoners will be set free. So this is a riddle which is given to elementary school students in China. How tall is the table? So we have 2 arrangements, a cat and a mouse, around this table. In the leftmost arrangement, the cat is on the floor and the mouse is on the top of the table, and the distance from the top of the cat to the top of the mouse is 130 centimeters. And in the rightmost one, they've changed places, and we now have 170 centimeters. So this seemingly tricky problem can be solved with a little bit of algebra. So let's first look at the first configuration. We'll let t be the height of the table, we'll let c be the height of the cat, and we'll let m be the height of the mouse. We can see that the length of 130 is the height of the table minus the height of the cat plus the height of the mouse. That is, t minus c plus m is 130. And now if we look at the second configuration, we can see now t minus m plus c is 170, since they've changed places. Now we'll find what t is by adding both equations. So from the left configuration, we had this, and from the right one, we had this. If we add the 2 equations, they're going to cancel out, and we end up with 2t. 130 plus 170 is 300. So 2t is 300, and that gives that t is 150. And that's the answer to our riddle. How can we solve this riddle? Maria weighs 100 pounds plus half her weight. How much does she weigh? Is it A, 100 pounds, B, 150 pounds, C, 200 pounds, or D, cannot be determined? Put your answer in the comments. Let's use algebra to solve this problem. We'll translate the statement into an equation. Let W be the weight of Maria. Then 1/2 W is half of her weight. Her weight is 100 plus half of her weight. We'll subtract 1/2 W from both sides of the equation. On the left, we'll get 1/2 W. and on the right we'll get 100. Next, we'll multiply both sides of the equation by 2. On the left we get W, and on the right we get 200. So her weight must be 200 pounds. Hence the answer is C. Alice is married and Charlie is not. Alice is looking at Bob, and Bob is looking at Charlie. Is a married person looking at an unmarried person? Is the answer yes, no, or can't be determined? You can pause the video if you like and think about it before seeing the solution. I'll solve this problem in 3, 2, 1. Let's look at 2 cases. First, suppose Bob is unmarried. Then a married person, that is Alice, is looking at an unmarried person, that is Bob. Next, suppose Bob is married. Then once again a married person, this time Bob, is looking at an unmarried person, which is Charlie. In either case we get A. A married person is always looking at an unmarried person. So the answer to our riddle is A, yes. Now here's our bonus problem. Santa has a drawer full of socks. He has 5 red and 5 green socks. He's blindfolded and he takes 3 socks out of the drawer. Does Santa have a matching pair of socks? Is it yes, no, or can't be determined? Leave your answer in the comments. On Monday, Maria read 30 pages of her book. On Tuesday, she read 1/3 of the remaining pages. She found she was halfway through the book. How many pages were in the book? Is it A, 60, B, 90, C, 120, D, 180, or can't be determined? We'll solve this problem using algebra. Let P be the number of pages in the book. After Maria read 30 pages, those that remaining would be P minus 30. And 1/3 of the remaining pages is 1/3 times P minus 30. So half of the total pages must be 30 plus 1/3 times P minus 30. That is, 1/2 of P is equal to 30 plus 1/3 times P minus 30. Now we'll solve this equation for P. First, distribute the 1/3 across the parentheses on the right side of the equation. Then 30 minus 10 is 20. Now we'll subtract 1/3 P from both sides of the equation. On the right they cancel out, and on the left note that 1/2 P minus 1/3 P is 1/6 P. So we end up with 1/6 P is equal to 20. Now we just multiply both sides by 6, and we get P is equal to 120. So the book must have had 120 pages. So the answer is C. Now here's our bonus riddle for extra credit. Roland bought a cow for $1,000 plus half of its price. How much did Roland pay for the cow? Was it A, 1,000, B, 1,500, C, 2,000, or D, cannot be determined? Leave your answer in the comments. Can you solve this viral riddle? In a room with 100 people, 99% are right-handed. How many right-handed people need to leave to bring the percentage down to 98%? This problem first appeared on the British game show called the 1% Club. Contestants had 30 seconds to solve it and could win £97,000. Some people might say it's one person. Does that work? But then we'll have 98 right-handed people out of a total of 99 people. But that's 98 divided by 99, which is 98.99%. I will show you 2 methods to solve this problem. We'll let X be the number of right-handed people who must leave. Then after they leave the room, we'll have a total of 99 minus X right-handed people left. And the total number of people in the room will be 100 minus X. So then the fraction of people who are right-handed will be 99 minus X over 100 minus X, which will then set equal to 0.98. We want to solve this equation for X. Let's multiply the left and right sides of this equation by 100 minus x. Next, we'll apply the distributive law. Now we'll subtract 98 from both sides and add x to both sides. Finally, dividing both sides by 0.02 gives the surprising answer of 50. So we must remove 50 right-handed people. And then we're left with a total of 50, 49 being right-handed. So here's our second method. Let t be the total number of people remaining at the end. Since we're left with 98% right-handed people, the remaining left-handed person must be 2% of the total. So we must then have 1 divided by t equal to 0.02. And when we solve this equation for t, we'll get 50 people remaining, which means we had to remove 50 people since we started with 100. Thanks for watching.